This is Stephen Reed from the University of Southern California, and today I'm going to show you how to create what's called a scalar value layer. Now, in emergence, sometimes we want to be able to represent a continuous value such as valence or intensity. But Leabra nodes don't do a good job of representing continuous values since they tend to have binary values, either close to 0 or to 1. So when you want to represent a continuous value, you can use what is called a scalar val layer or a scalar value layer. So to create a scalar val layer, you do the following. So I have a project here in which I had a network learn various stereotypes such as age, gender, occupation, or race from a set of input features. And what we're going to do is represent sort of evaluation of an individual based on their race. So what we do is first we create a new layer, and what we do is, one way to do it is we can click on this grid around the network, and then once we do that, we can sort of do like this Leabra network, and you can go down and it says new layer, and basically you create a new layer. The new layer has this default name, and basically what we want to do is we want to change a couple of aspects of this layer. First thing we want to do is we want to make sure that the node, or that the layer has the number of nodes required for the particular kind of scalar value layer you're going to create. The particular one we're going to create needs 12 units. So the first thing we're going to do is we're going to change the name, and since we're just going to call it evaluation, or actually let's call it positive, because we're just going to represent positive evaluation. And then we have to change what's now a 1 by 1 layer to a 12 by 1 layer. Okay, and hit apply, and we now have the new layer, although it's empty. So basically what you have to do is go to network over here, and then when you get the box you click on build, and then what that will do is it will fill in the nodes in the network. Now the one other thing you need to do with this network is you'll notice that this layer is currently a hidden layer, and you don't want it to be a hidden layer, you want it to be a target layer. So you need to change it to a hidden layer, a target layer, so it will behave properly. It's also the case that you need to change it to a target layer so that the input data tables will be updated properly to represent this. Okay, so now what we need to do is we need to connect this scalar value layer to race. We can click on positive, it's already selected, then we shift click on race, and then we control or right click, go to Leabra layer, and then choose connect bidirectional. It's now connected things. You want to hit the connect button to make sure the network's connected, and then actually the other thing you want to do is you want to click on network and then click on build. Okay, and now it's put in the connections that you need. Now once you do that, you then want to make sure that this layer is in your input data table. So what you need to do is you go to the Leabra wizard, go down here to this network menu, and choose update input data from net. And normally it'll probably have this will be blank, or it'll say null. But in this particular case we actually want to update the data table standard input data table. Normally what you do, if you want to select a data table, you click on this and then you can have a choice. We're basically going to stick with what's already there. You say OK, and then what it'll do is it'll update the standard input data table. Okay, and now over here you see positive over here in that network. Okay, now once you've done that, now what you need to do is you need to go back to the layer, and you need to change its attributes to fit the attributes of a scalar value layer. So basically the first thing you have to do is you go down to the layer spec, and right now it says it's a it's a Leabra layer spec, and you want to change this to be the Scalar Val layer spec. So you get your dialog box, click on Scalar Val layer spec, and there you are. Now the thing you want to do is you also want to be able to change the particular spec. You want to make it, so this is the type of spec over here, and now you want to create the actual spec. Now at this point this is grayed out, and one of the things you can do here is if you go to network and then say build, okay, it should now be the case that when you go back here, now it actually has put in a Scalar Val layer spec, so that's what you need. So now what you need to do is, now that you have that, you then have done those two things, then you need to edit the Scalar Val layer spec so it has the attributes that you need for a scalar value layer. Click on that, you edit, and then the Leabra documentation will tell you how you want to set inhibition, and then also how you want to set these things down here called scalar and unit range. Okay, so the first thing we do is inhibition. We're basically doing, for one thing to bear in mind, in this particular case we're creating what's called a Gaussian bump scalar value layer that has 12 units. And we've already created one with 12 units. The other things we have to do are we have to change the inhibition. So we have KWTA average inhibition, which is fine. We want K equals to be equal 3 instead of 1. And then KWTA point up here, PT, should be 0.6. Okay, we say apply. Okay, and now some other things we have to do. If we go down to scalar, we want to change localist to Gaussian, and we need a unit range where the minimum is actually going to be minus 0.5 to 1.5, so that we're basically creating a range that's larger than the 0 to 1 we're trying to represent. Now, up here where it says Gaussian, the other thing we want to do, where it says unit width, we want to change that to 0.2, because basically what is happening is this representation is basically going along in sort of units of 0.2. Okay, and now basically that's what you have. You now have created the characteristics of the scalar value layer, so it will now give you a Gaussian bump distribution. Now, there are two other things you have to do for this to work properly. One is you have to go into your data table and modify the column that corresponds to positive. So it now, basically what you want to do is you want to change it so that instead of having what's now a 12 by 1 matrix, you want a 1 by 1 matrix. The way the scalar value layer works, the routines in Leabra only apply activation to the first node. So basically what you have to do is you have to take this column, and right now you have a 12 by 1 matrix, and you now need to change it to a 1 by 1 matrix, but it has to have 2 dimensions. Okay, so you click on that, and you click on the column, and then you go down to change column cell geometry, and it'll give you a dialog box that says new geometric dimensions, new geometry dimensions 2, which is fine. And then right now it says 12 by 1, and you want to change this so it's 1 by 1. Okay, now if you look at the matrix, you have a single cell, but notice that this is represented as a matrix and not a scalar value. If you do a scalar value, it won't work properly. Okay, and finally the thing you want to do is you've created this scalar value layer to represent, say, positive evaluation, but you now want to track that positive evaluation, and you now want to store that, say, in an output data table. So what we need to do is we go back and we click on positive and highlight it, and we get the dialog box that controls that layer, and down the bottom it says monitor var. And what we want to do is we want to click on that and create a new monitor var. And in this particular case, we're going to take the activation from here and we're going to write it to an output data table. And in fact, let's see, we're going to do netmon, and we have a couple of choices. We can do epic. At the epic level, we can write the data from the network to the epic output data. We can do it for a test data program, or we can do it at the trial level into trial output data, or at the trial level into trial test output data. In our case, we're going to actually put it into the trial output data program. Okay, we hit OK, and now it asks us what variable we want to record. One possibility we might want to record is the act EQ, and you need to use act EQ and not plain act, because plain act won't work properly. But now in this particular case, you only want to record the activation from the first node in the layer. You don't want the activation from all the nodes. And there's a particular way in Leabra where you can basically specify that you only want the activation for a particular node. And the way you do that is you can basically say units, bracket, open bracket, 0, close bracket. What this will do is it'll track unit 0, which is the first node in the layer, period, and then ACT underscore EQ. You say OK, and now what's happened is that you now have this thing called positive units activation that are now being tracked by the trial monitor, and they're now actually being written. If you look at the trial output data table, you now see that this actually it's not in the trial output data table yet. So what you need to do is go to train, say init, and now it actually puts it in the trial output data table. So you see right here you see positive units, and it's in the trial output data table. Okay, and the one last thing I want to mention is if you don't like this really funky name, positive units 0 act EQ, you can actually change that name. Okay, so basically this is how you would add a scalar val layer to an emergent project. So in this particular case, we can actually basically be reading off the evaluation that we have for somebody based on their race.